In this video, we're going to run through how to calculate the singular values of a matrix, and this is actually really quite simple. So we'll start by going through the basic procedure, and then we'll run through a worked example. So let's imagine we've got a matrix A, and that matrix is a square or a non-square matrix. Doesn't matter. The first step is we calculate A transpose A, and that product will always give, absolutely always, a square matrix. And that means we can work out the eigenvalues, because we can't work out the eigenvalues of a non-square matrix, so that's why we have to do A transpose A. The next step is, because we know that A transpose A is always square, we find the eigenvalues. And as is the normal procedure with finding the eigenvalues, we take the determinant of A transpose A minus lambda, which is the eigenvalue, multiplied by the identity matrix. And that is all equal to 0, and that lets us form a polynomial which we can solve. And the singular values are found from the non-zero eigenvalues of A transpose A. Worth remembering non-zero. And the way we take the eigenvalues and turn them into singular values is we simply find the square root of the eigenvalue. Let's run through a nice simple example. So we've got a 1, 2, 3, 4, 5, 6 matrix, and this is of course non-square because we have 3 rows and 2 columns, so they're not equal, giving us a non-square matrix. So we start by finding A transpose A, which is just basic matrix multiplication. We've got 1 times 1 plus 4 times 4, which gives 17. Then we do row times column again, getting 22, row times column again, getting 27. And we follow that procedure through and we get A transpose A. So we started with a non-square matrix and we've ended up with a square matrix with 3 rows and 3 columns. We've got n equals m, nice square matrix. We then take this matrix and we find the determinant of A transpose A minus lambda I, and that gives us this result. So we take the determinant of this, and that gives us the characteristic polynomial. So if you're not sure how to find the determinant, you'll need to look that up. We're running quite quickly through it. And when we solve that equation, we get 3 solutions. We get 0, 0.597, and 90.4. Remember what I just said about non-zero. All right, these are the eigenvalues, keyword eigenvalues of A transpose A. They are not our singular values. So we need to find the singular values of A. So we take the square root of the non-zero eigenvalues, and that leaves us with the singular values of our original matrix A. Hopefully this tutorial has been helpful to you. You may need to rewind it to go through some bits again, but ultimately the procedure is very straightforward. Thank you for watching. Hopefully you found this useful.